Hi, it's Terry Dennery of the MathWorks. So welcome to part 2 of the crane problem, right? So in this one, all right, we're going to do these reaction forces. So basically, we're going to make a choice here, right? And the choice will be to choose these. I'll call it this world orientation, and this direction here, that'll be my y direction. So we're going to solve for the reaction force y. All right, and then to kind of keep it right-handed and occurring at that bearing, our x will be like this, that direction, and that's positive in that direction. Okay, so let's hit escape and let's just kind of get to work on this. Well, you can kind of see that mg and weight are both in the y direction, so this will be part of the calculation for the y component. And it's really only this tension that really has both x and y components. And I'll use this little trick again too. This time I'm going to just draw hopefully a nice straight horizontal line like that. And I want to use this kind of identity that I recall from my, what was that? Probably 9th grade geometry class, maybe 10th grade, which is, what do they call it? Inverted angles, whatever, opposite angles on, that are formed when a line crosses two parallel lines. Well, those will be the same angle. And I need to do this because I need to get what this complementary angle here is complementary to 10 degrees. And so based on this, whatever geometry axiom, I know that the two will add up to 30, right? And so I'll just kind of define a new angle. I'll call it gamma. And gamma, we can see, will be equal to 20. Right? But again, I kind of like creating variables because things could change, and the idea of reusing and parameterizing this well is always a good thing. So let's get in this mode. I'll say gamma DEG is equal to theta DEG minus alpha DEG. Right? Learn another one too, F5. See that? It calculates, right? So, all right, and now let's get gamma rad equal gamma times pi divided by 180. Okay, so with that, now we can kind of make one more reference to the picture with that horizontal line, that new gamma. We'll see that the cosine will be in the x direction, and then the sine will be in the y direction. Both of them will have negative values too. So, all right, and so we got Tx is equal to T times cosine gamma rad, and it will be a minus. Ty. And this time will be sine. And then we got that there. All right, and so now it's just sum of forces in the x and sum of forces in the y. I'd say x is a little bit easier because I'll call it f sub x plus tx is equal to 0. Therefore, because they add 0, therefore it's simply minus tx. All right, and now let's get fy. Fy is a little bit more. And this could basically be f minus mg minus weight minus the y component of t will be equal to 0, and therefore we can kind of do that math, and we'll get this could be equal to minus ty plus, probably should have created the force variables, but I didn't, so let's just kind of do it. So we'll go in being times G plus M weight times G. I think I got it. So let's again hit F5, and there's our Y force. So I think that pretty much wraps up this problem. What I think is kind of cool about this, and I'll probably do a video on this sometime in the near future, is I'll build this in Simscape multi-body, and through Simulink, we'll simulate the overall system. And we'll also just kind of look at, that we can reproduce this result, but we can also do that dynamic calculation and figure out, what are those forces going to be as you winch in that blue line and you bring that pivot up, and we got all kinds of interesting geometry changes that will take place, and we got a very interesting nonlinear problem on our hands. So anyways, I'd say that kind of down the road option, with MATLAB, that you can kind of bring it to all the cool things that you can do with the full line of products of MathWorks, and especially, from my perspective, I love to kind of go into that direction with Simulink and develop real rich, engineering systems with really interesting controls. So whatever, hope you like this video. I'm definitely having a lot of fun doing this, and please offer me some comments. Let me know what you think. All right, thank you. Bye.